Hello! This video is going to walk through Project Lead the Way's 3.2.1 Trends in Temperature activity, starting with step 20 and taking us through step 31. So this is kind of the middle of the project. So in the first section of the project, we worked on taking a data set and making a line graph with it using MatPlotLib as well as the Pandas module. So now we are going to use those modules, MatPlotLib and Pandas, to work on making a bar chart from the same temperature data. So we are going to read a little bit about the fact that matplotlib.pyplot offers some other options for plotting than just making a line chart. For example, we can make a bar chart. What is a bar chart, you may ask? I think you've probably seen one. Data is represented in this two-dimensional way that shows bars at different heights representing a quantity of data. So what are the axes? We're going to have one axis showing the categories and another axis showing the measurements or the quantity of each category. So in our case, we are going to have the years be on the x-axis and the temperatures on the y-axis. Here are some other options that can be specified in our bar chart. The alignment, maybe it's going to be a vertical chart or a horizontal chart. Color is another option, and we're actually going to use that option today. So let's get to it. So we are going to use this code here. Project Lead the Way is giving us some code under to-do number 4 in order to create the bar chart. So let's go ahead and copy what's here and find our CodeHS project. Oh, of course, we need to open it. We're looking at Unit 3, Trends in Temperature. This is still part of the temperature analysis. And we are going to go ahead and add this to, this is number 4, right? To do number 4. Right here. So I'm just going to comment out the plot.show over here because we're going to use it down here instead. So we are graphing just to show all of the configuration we're doing. This bar function in the MatPlotLib library is what gives us the bar chart. Our first argument is the data for the x-axis, so that is going to be the years. The next argument is the data for the y-axis, and in our case we're choosing anomoly. Just to remind you of what the data is, the year is the year that the temperature data was collected, and anomaly is how much this data differed from the average temperature we were seeing between 1950 and 1980. So some numbers are negative because they were below that average, and some numbers are going to be positive because they are above that average. So back to our code. We also, in addition to having our x-axis data and our y-axis data, we're telling how we want to align our bars and what color they should be. We're making green bars in this case. We're also defining that this plot's y-axis label is going to be temperature anomalies in Celsius, and the x-axis will have a label of years. The entire graph will have a title, Change in Temperatures. And now, if we do all that, but we don't include the plot.show command, we're not going to see anything. So we always want to make sure we include plot.show. Let's go ahead and run our code and see if we can see a bar chart. Well, here we go. So you can, of course, see we do have our green feature. We do have our years on the x-axis and our temperature anomalies on the y-axis. And you can kind of think about for yourself if you like this representation. We're basically getting to see the extent and the direction of the anomalies. So it does look different from the line chart. That's kind of one thing that I'd like us to think about. Do we have a preference between seeing this data, the same data, as a line chart or a bar chart? So now that we have completed these tasks, we are good with our bar chart. We did it. We are going to go on to look at the min, the max, and the average. These are really helpful values to access in order to have a full understanding of the data that you're working with. If you can, sometimes you see a vast, huge data set. You want to have some basic statistics so that you have a sense really quickly of what you're dealing with, rather than having to read every single value. These are some summary elements. So if we know what is the minimum value, what is the maximum value, what is the average value, we have a sense of what we're looking at without having to spend so much time combing through every single value. So let's start by finding the minimum and the maximum. First, we're going to actually initialize variables. Project Lead the Way gives us the variables that we will need in order to calculate these statistics. So I have copied my variables. I'm going to code HS. I'm going to do number 5. You may have noticed we're looking at to do number 5, right? That's in the instructions. So I can find that to do number 5 in my code, and this comment on line 29 in my case. Yours might be on a different line, depending on how you've spaced things out. But here is our code. We have initial value of 0 for the, well, I should say there's an initial value of 0 for the location, for the index that we're looking at in the temperature data anomaly list. And we're going to just assume, it may or may not be true, that the first value in the list is the minimum. And we're also going to assume that the first value in the list is the maximum. And as we go through these values in our for loop, we're going to keep comparing. And if we find another value that is smaller, then we will overwrite this initial assumption. By the same token, if we find a value that is larger than the value in index 0, then we will overwrite our current assumption, which is probably false. It's just kind of, we've got to start somewhere. We're going to start at index 0, and then we're going to go on and compare things. We're taking the same strategy for the minimum year and the maximum year. And then we're also going to start with our sum at 0 and our average at 0. And as we work through things, I'm sure that we will overwrite those values. So this is just initializing our variables. Add the following code to loop through the anomalies and find the minimum value. What does this code do? Well, it's kind of doing what I was talking about when we initialize the values. We're going to look at every value in the every index, I should say, in the anomaly list. And if the value at that index is less than our current assumed minimum, then we're going to say, aha, here's a smaller value. Now the minimum value should be equal to this current value that we're looking at because it's smaller. And then we're also going to compare the year. So if the current year is, if that anomaly was the smallest, we want to know what year was it in. So we look at whatever the current index is. The year list at that index is the year when the anomaly was the smallest. So we want to record that as well. So we are going to copy this code and include it under to-do number 5. Great. We have another challenge here. Add a similar if statement to the for loop to determine the maximum anomaly and its corresponding year. So we want something a lot like this, but we're looking for the maximum. So I think I'm actually going to copy that and see if I can recreate it here. Wait a minute, this should all be in the same for loop. So if the value at the current index is greater than the current max anomaly, let me copy and paste so I don't have any typo problem, then the max anomaly will get the value of the current index's value, and then the max year will get the value of the current index's year value. So I think that should work, and I can even check my code. This is pretty much what we did. Yep, we have a greater than. I think that looks good. Next, we're going to add a line of code to the for loop to calculate the sum of the anomalies. So if you're going to add things up in a for loop, we can use this value, right? Sum anomaly. We don't need this to be in an if statement, but we do need it to be within the for loop. Sum anomaly is going to be equal to its current value plus basically the current anomaly value. So I'll call it this, right? The temperature data anomaly list at the current index. Great. We can check our code here as well. That looks like what we have. Great. After the for loop is complete, add a line of code to calculate the average anomaly. So when the for loop is complete, we're going to say the average anomaly. Let's copy and paste again. Should be equal to, I would say, the entire sum divided by, I think, the length of the data, the number of items in that list. I think that looks good. I can always check my code. Yeah, that looks good. Add print statements to display the minimum anomaly and year, the max and the year, and the maximum anomaly and that year, and the average anomaly. So in this case, since it lets me check my code, I think I'm just going to say, that looks good, project lead the way. Let me use your code. I will, of course, fix the typo. And let's test it. Step 29, test your code and make sure it runs correctly. You might want to fill in your value here. You could even compare it against mine if you want to, once you run your code. I'm going to comment out the plt.show so that we're not focusing on the graph, we're just focusing on the statistical values here. Let's see what gets printed. The maximum anomaly is 0.98, which occurred in 2016. The minimum anomaly is negative 0.49, which occurred in 1904. Wow, that looks good. And then the average should be 0.0323. That looks good. So give this a try. See how much you can code without copying and pasting all of the code that was provided for Project Lead the Way to check our work. It might help you to build your programming skills if you can kind of work through this on your own. But of course, please do check the code as you're testing, or if you're very frustrated, go ahead and peek. So we have concluded through step 31 here. I hope that you are enjoying this project, and I will see you in class or the next video.